Oh, hello, young people. Mr. Caldwell here again. Wanted to give you a quick little video review of the ideas associated with charge and talk a little bit more about the role of coulombs as it relates to the charge of an individual electron. So we charge ahead, terrible joke. We're going to charge here, and I think you need to remember that opposite charges always attract. Positives and negatives are always going to be drawn towards each other. And if opposites are going to attract, that means that like charges are going to repel. So I drew two little scenarios here. I have a positive charge here and a positive, and they're going to be flying away from each other because they're the same. They're like, hey, I am not interested in you. And they fly apart. You can also get like charges, a negative is going to repel from a negative. Repel means go away, right? So just remember opposite charges attract and like charges repel. Super important, and it explains basically so much of a static electricity phenomena. All right, so how does an object get charged? Remember, it gets charged by gaining or losing electrons. Electrons, they're on the outside of the atom. And so when atoms interact with each other, it's kind of like the handshake. Those electrons are the things that interact. So electrons are the things that are gained or lost. And I think I went over this in another video, but maybe you didn't see that. Maybe you don't have access to that. But since electrons are negative here, what we want to remember, and this is always tricky for students sometimes, so be real careful. So if we have a neutral object, remember a neutral object is going to have the same number of positives and negatives. All right. If I gain electrons, well, if I throw a couple more electrons on here, since electrons are negative, I would have more negatives than positives. So gaining electrons, even though it's sort of counterintuitive, you're gaining electrons means that the object is becoming negative if we're starting out with a neutral object. However, if we lose electrons, if I were to scribble these out and take them away, all of a sudden, I have three positive charges and one negative. So my overall charge would be positive because there's more of the proton, more of the positives than I have of the negatives. So that's just sort of a review, hopefully, of some of the fundamental pieces with static electricity. All right, now we're going to dig into a little bit of math here. All right, one electron has a very specific amount of charge, all right? Just like a penny is worth 1 cent, a dime is worth 10 cents. One individual electron has a very specific charge. Since electrons are negative, it's negative 1.6 times 10 to the negative 19th. That's a very, very, very small number, all right? Now, I don't know if you all are using the scientific notation on calculators, but boy, I don't want to type in 1.6 times 10 to the negative 19th over and over and over again. So if you're using sort of an iPhone or something like this, you're going to look for this EE notation, all right? What that EE is, right? That EE takes the place of the times 10, and then what you put in next after you hit EE is just your exponent. So if I'm going to do a negative 19, I'm going to hit 19, and then I hit the little plus minus sign to throw a negative sign on there. Don't use the subtraction button over here for negative signs. Messes the calculator all up. So if I'm going to do 1.6 times 10 to the negative 19th, let me just repeat that. I'm going to go 1.6 EE. Whoa, should clear that out, all right? And technically, since I'm talking about an electron, it's really 1.6. It's a negative 1.6. And then I'm going to hit EE. And now what the calculator is expecting, whatever I put in, is this exponent that I have on the times 10 to the. So I'm going to go ahead and type in 19 negative. All right. So that's how you put in 1.6 times 10 to the negative 19th. All right. Now, so if I think about what 1.6 times 10 to the negative 19th is, like the calculator, if I just hit the equals sign, it doesn't even show that, because really what we're talking about is 0.0000000, lots of 0.00s, And after we've gone far enough, then we would throw a 1,6 in there. But I don't even have enough space to go because I have 19 spaces that I've got to move. Okay. Now I'm not going to get into scientific notation and all that jazz, right? But suffice to say, you don't want to type that into your calculator every time. Much, much better to go 1.6 and then E19 with a little negative sign there if you're using a iPhone. So if I'm talking about 1 coulomb of charge, my goodness gracious, that is going to be an astronomically big number of electrons. And so what I want to do real quick is show you how we could go about figuring out the sort of the conversions between the number of coulombs and the number of electrons. And so let's look at an example. How can we use the facts above to figure out how many electrons give a certain charge or vice versa? And so I'm going to scoot this up here and let's see what we can come up with, all right? A neutral object loses 428 electrons. What is the charge? All right, so watch what I'm going to do. I know that I'm starting out with 428 electrons. I'm going to just go ahead and write elec. All right, now I can put that over 1 because anything divided by 1 is just itself. And then I'm going to be a little bit slick. Since I know that 1 electron, 1 elec, is exactly equal to a negative 1.6 times 10 to the negative 19th coulombs. That's like my conversion factor, right? And so just like we can say that the 12 eggs is a dozen, right? Anything divided by itself is the number 1. So since 12 eggs is a dozen, right? If I were to write 12 eggs over 1 dozen, or 1 dozen over 12 eggs, as weird as that is, those are just funny ways of writing the number 1. All right. And when we multiply by 1, we don't change the value of the number that we're dealing with. So this is a really sneaky way of getting to an answer. And you may have learned this in chemistry. It's called dimensional analysis. I certainly hope that you learned it in chemistry, but let's go ahead and do this real quick. So what I'm going to do is I'm going to say, let's multiply. I know that 1 electron can go in the bottom because if I have electron in the top and electron in the bottom, I can cancel them out. All right. And what do we know 1 electron is? We know that it's negative 1.6 times 10 to the negative 19th coulombs. So at this point, I'm going to pull out my calculator and I'm going to turn it sideways. All right. And let me see if I can scoot this down so that you can see everything. And so what I'm going to do now is I'm going to take and I'm going to type in my very funny 1.6, right? And then I'm going to go EE. And then I'm going to go 19 negative. All right. So that's my 1.6 times 10 to the negative 19th with a negative sign in front of it. And all I'm going to do is I'm just going to multiply it by 428. Right? And so when I look at this, right, that top, because these are fractions, and when you multiply fractions, you multiply across the top, you multiply across the bottom. The bottom is easy. 1 times 1 is 1. So up top, what have I got? The only unit that's sitting here is coulomb. And so what I'm going to write is this is negative 6.848. That E negative 17, I can rewrite that as times 10 to the negative 17. Sorry for squeezing this in here. And then remember that the charge is measured in coulombs. That's the unit that we use. It's just named after an old French dude. So we use this little conversion factor to help us go between electrons and coulombs. If we can go between electrons and coulombs, we should be able to go between coulombs and electrons. So let's try one more real fast and see if we can get this one squeezed in here. So I've got a hairbrush that has a charge of negative 2.2 coulombs. How many electrons did it lose? So we go back and we remind ourselves of our conversion factor. This time we're starting out with negative 2.2 coulombs. And let's go back and remind ourselves we've got the conversion factor, so I can put this over 1. And since I want to get rid of coulombs, I'm going to go ahead and put the amount of coulombs in the bottom of my fraction this time. Negative 1.6 times 10 to the negative 19th coulombs in the bottom. And then I know that that's equal to 1 electron. Now, before I do the math, let me just answer this. If something is negative, remember what we said, an object that is negative became negative because it gained electrons. So if it's going to gain electrons, we can go ahead and do that. And I am going to throw this in the calculator, see what we get here. All right, sorry about that. A little tricky trying to do all of this at once. And so here we go. So I'm going to take my 2.2 and I multiply that by 1. So it's just 2.2. Don't forget the negative sign. All right. So I'm going to go 2.2, little negative, and then I'm going to divide that by this, right? Because this times 1 is just going to be this. And so I'm going to end up with 1 point, whoa, punched it in wrong, 2.2 negative divided by 1.6 negative EE. And now I go 19 negative. And lo and behold, my coulombs cancel out. The only unit left is electrons. My goodness gracious, 1.375. E, remember E represents times 10 to the, and the exponent is a big fat 19. So that if we wrote it out would be a horrifically large number. I'd have to move the decimal 19 places to the right. I am not going to do that because that is just too much. So I hope that you are well and that this little video helps you just a tiny bit. Okay, be well, and I hope to see all of you soon. Take care.